All right, so like I said, page 285, and today we're going to talk about isosceles and equilateral triangles. Isosceles and equilateral triangles. And an isosceles triangle has two congruent sides. The two congruent sides of an isosceles triangle, those are each called a leg. The third side that's not congruent to those two is called the base. Now, in an isosceles triangle, you've got the two congruent sides and the angles opposite those sides. The angles opposite the legs are also congruent. And those are called base angles. So you've got two legs, which are the congruent sides. You've got the two angles, the two congruent angles that are opposite of those legs. Those are called the base angles. The third side of the triangle that's not one of the two congruent sides, it's called the base. And then up in the top, across from the base, you've got what's called a vertex angle. So in isosceles triangles, you've got two congruent sides. You've got two congruent angles. And now that rule works vice versa. Meaning, if the base angles of a triangle are congruent, or if two angles of a triangle are congruent, then the sides opposite of those angles are also congruent. So you'll see two different applications of that rule today. So let's look at page 285, example 1 down there. And we've got this triangle. A, B, C, D. Actually, we've got two triangles here. And here's what you're given. Angle D is congruent to angle ACD. And side AC is congruent to side AB. And then you're asked to name unmarked congruent angles and sides. Name unmarked congruent angles and sides. All right, so starting with this first triangle here, triangle ACD. DC would be the base, right? And since these two angles are congruent to each other, then side AC is going to be congruent to side DA. If two angles in a triangle are congruent, then the sides opposite those angles are congruent. So our unmarked congruent sides would be AC is congruent to AD. And then if we're going to name our unmarked congruent angles, if side AC is congruent to side AB, then angle ACB is congruent to angle B. So our unmarked congruent angles would be angle ACB is congruent to angle B. Everybody see that in regards to isosceles triangles. Two congruent sides, two congruent angles. The sides opposite the congruent angles are congruent, and the angles opposite the congruent sides are congruent. So we need to now, let's find each measure. And we've got another triangle here. And let's say we got MNO. We're told that angle O is congruent to angle N. And we're told that MO is equal to 10. And we need the length of segment or side MN. All right, so it's kind of just as simple as that, guys. If angle O is congruent to angle N, then isn't side MO congruent to side MN? Sides opposite the congruent angles are congruent. So if MN is 10, if MO is 10, then MN is also 10. Good with that? Take a look here. Let's say we get this triangle XYZ. We're told that angle X up here is 80. And that X to Z is congruent to X to Y. And if we're finding each measure, we need the measure of angle Z. Now, this is basically the question from your quiz last week, the A-frame house, right? If two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So we can give each of these angles a same variable because they're the same as each other. So I'm going to call this angle A and this angle A. So if we need to find the measure of angle Z, we're going to write an equation. What do these three angles need to add up to? 180. Very good. So we've got an A plus an A plus an 80 that needs to sum 180. So our 2A plus 80 equals 180. Subtract 80 from each side. So our 2A is equal to 100. And then divide both sides by 2. So our A in this case is equal to 50, which means that the measure of our angle Z is equal to 50 degrees. We okay with isosceles triangles? Two congruent sides, two congruent angles. Use those rules to write any equations that you need to solve for angle measures or side lengths. All right, so then on page 286, down at the bottom, we're talking about equilateral triangles. Equilateral triangles. Equilateral triangles have three congruent sides and three congruent angles. Equilateral means equal sides. Equiangular means equal angles. So all equilateral triangles are equiangular, and all equiangular triangles are equilateral. So if you have a triangle and you're told that all the sides are the same, this triangle, we'll call it MNO right now, has three congruent sides. If a triangle has three congruent sides, then it has three congruent angles. And vice versa. If a triangle has three congruent sides, then it has three congruent angles. And if angle M plus angle N plus angle O has to sum 180, and they're all the same, then what are they each equal to? 60. They're each equal to 60 degrees. The converse of that is also true. If you have a triangle, and let's call the triangle ABC, and let's say that you're told that angle C is 60 degrees and angle B is 60 degrees. What would the measure of the third angle be? It would be 60, right? Because if two of the angles inside of a triangle are 60 degrees, the third angle has to be 60 degrees. So if all the angles in a triangle are 60 degrees, and side AC is equal to 12, then what is the length of side AB? It's 12. And what is the length of side BC? 12. So that's using the rule both ways. If you're told that all the sides are the same, you know that all the angles are 60 degrees. If you're told that two of the angles are 60 degrees, well, then you know the third angle is 60 degrees, and by rule, all the sides are congruent. Make sense? All right, so let's look at the bottom of page 287, example 3. And again, you're just going to use this rule today to write equations to solve for variables and or angle measures or side lengths. So you've got a triangle there. And you're told that all the sides are the same. We've got ABC. Angle A is 2x, and angle B is 2x. Side AB is 3, and side BC is 4y minus 5. Find the value of each variable. All right, so looking at this triangle, it's got 3 congruent sides. So aren't all the angles congruent? And if all the angles are congruent, what's angle C equal to? 2x. What's each angle equal to? Come on, well, what's each angle measure equal to? 60, right? So if we had to solve for x, doesn't 2x equal 60? And we can divide by 2. And x equals 30. So there's your first variable. If all the sides are the same, then side AB, which is 3, is equal to side BC, which is 4y minus 5. So we add 5 to each side. Our 8 equals 4y. And then divide both sides by 4. So 2 equals y. All right, let's look at one more. Let's look at the guided practice down on the bottom of 287. And now we've got this triangle. All right, be careful here. We've got a triangle with 2 congruent sides. We've got an angle that's 80 degrees. So the first thing you want to ask yourself here is, if this angle is 80 degrees, is this triangle equilateral? No. If this angle up here was 60 degrees, then all the angles would be 60, wouldn't they? But since this angle is 80 and we've only got 2 congruent sides, that makes it an isosceles triangle. All right, one of these base angles is 6x plus 8. One of the sides is 4y minus 2. And the other side is 2y plus 2. So let's solve for y first. We got the two congruent sides. So 4y minus 2 is equal to 2y plus 2. Subtract 2y from each side. So 2y minus 2 is equal to 2. Add 2 to each side. We get a 2y that's equal to 4. And then divide both sides by 2. So we get a y that's equal to 2. Everybody all right with that? Now, there's a couple of different ways that you can do or solve for x. Okay? You could make this angle down here 6x plus 8. And you could write a big equation, right? 6x plus 8 plus 6x plus 8 plus the 80 has to equal 180, right? But watch. If I redraw this triangle smaller, and these two sides are congruent, and this angle is 80 degrees, what do these two angles equal? Aren't they the same as each other? What's 180 minus 80? 100. And what's 100 divided by 2? 50. So aren't these 50 each? Agreed? They got to be the same as each other. So we got a 50 and we've got a 50. Let's do that again. Make sure you understand that. Don't write this part. Just watch for a second. Look, if we've got this picture, two congruent sides, and a vertex angle of 100 degrees, these two angles are congruent. What are they each equal to? 40. Right. If you take 180 and you subtract the 100, you're left with 80, right? If you divide it by 2, you're left with 40. So these are 40 each. If you take the vertex angle, subtract it from 180, divide it by 2, it gives you the base angles, doesn't it? So it's a shortcut. Instead of writing this big long equation to solve for x, what does the 6x plus 8 equal? 50, doesn't it? So it's a much shorter equation. So our 6x plus 8, 8 is equal to 50. So subtract 8 from each side. We get a 6x that's equal to 42. And then divide both sides by 6. So we get an x that's equal to 7. All right, so any questions on using the rules to solve for variables in equilateral and isosceles triangles? All right, your practice for today is on starts on page 289. I want you to do 3 through 6. And then over on the next page, 15 through 22. Make sure that you're checking your odd answers. And that you're doing your electronic assignments. Those electronic assignments were intended to be done nightly. Some of you guys are getting further and further behind on your electronic assignments, and that's not the purpose. I'm leaving the assignments open for multiple days for the people that are sick and they missed some school and they need some time to make up the work. Not for you to wait until Friday to do all your electronic assignments. So those need to be done regularly. After you finish each assignment and you've checked your odd answers and you're comfortable with your odd answers, do the electronic assignments. If you're not comfortable with your odd answers, then you need to see me and get some help so that your even answers are correct. All right, so any questions on what we talked about today?